Welcome students again into the 12th Science Chemistry class. We are learning the chapter number 1 solid state, and into that we are learning from few lectures the imperfections or defects in the crystal or ionic compounds. Now up to the last lecture we learned the point defects, and in point defects there are the that is 4 types of point defects. That is self-interstitial defect, vacancy defect, Schottky defect and Frankel defect. There are mainly 3 main defects, that is the point defect, line defect and plane defect. But in this standard we have to learn only the point defect, and into that point defect there are these 4 types of defects are there. Now let us learn the 4th defect, that is the Frankel defect. Frankel defect arises when an ion of the ionic compound is missing from its regular lattice site. Now generally the cation lose its regular position or original position, and it shifts or displaces in the interstitial space, because cations are generally smaller than anions and they can be accommodated into that void or interstitial sites. So Frankel defects, in Frankel defect generally cation miss its regular or original position. So Frankel defect arises when an ion of the ionic compound is missing from its regular lattice site, and that ion is regularly or generally cation, that is the positive ion. And this positive ion or cation occupies interstitial position between the lattice point as shown in the figure. Now this is the figure of the ionic lattice or crystal lattice. Now in this, these red colored, that is the ions, are the anions, negatively charged ions, and the blue colored ions are the cations, that is the positively charged ions. Now this is the site because they are alternately placed, cation and anions. Now this anion cation will be there, but this cation get missing here. So due to that, vacancy of the cation is developed at this position, and this cation accommodate the interstitial space. Now see this is the interstitial space. Now these are the regular position of cation and anion, and in between that is the sites or the interstitial space, or it will be also called as the voids. Now this cation which shift or displaces from its regular position or its original position, and it accommodate into that is the interstitial space or void. So there is cation at the interstitial site. Again this is the another layer, into that again cation anion. Now this cation here also gets shift or displaced and its original position from its original position. So due to that, vacancy of the cation is developed. That means this Frankel defect is the combination of the vacancy defect and interstitial defect. Now the vacancy defect is found at that site, at the original site of the cation from which it displaces, and the interstitial defect is observed into that point or that space in which that cation is shifted. Now here also this cation is shifted here in the that is the hole or void or interstitial space. So due to that, cation at the interstitial site. Now this you are observing here, these cations are smaller than the anions. Now these are the anions having the negatively charged, the red color anions are there, which are somewhat bigger than the cation. Now this is the about the Frankel defect. So Frankel defect arises or found when an ion of the ionic compound, that is generally the cation, is missing from its regular site and occupies the interstitial space or void between the lattice point as shown in the figure. The cations are usually smaller than the anions. It is also more common to find the cations occupying the interstitial sites. Generally, it is common that the cations occupying the interstitial sites because cations are generally smaller than that of the anions. It is easier for the cation or smaller cation to accommodate the interstitial space because their size is somewhat smaller, and due to that they can be easily accommodated into that interstitial site or space. Now it is important to note that the smaller cation is displaced from its normal or original site to an interstitial space. Now these smaller cations can be displaced from its position into the interstitial space. This is very common. Now it is therefore creates a vacancy defect. Due to that, what happened? I already told you. There is the vacancy defect is developed at that site from which the cations is displaced or it lose its original site. At that original site from which the cation is displaced, there is formation of the vacancy defect. So, vacancy defect at its original position is formed or create, and interstitial defect is created at its new position. And therefore, Frankel defect is the combination of the vacancy defect and that is the interstitial defect. So, thus Frankel defect is regarded as or called as or represented as the combination of vacancy defect and interstitial defect. Now, let us learn the conditions and consequences of this Frankel defect. Now, pay attention students on a blackboard. Now, here there are some conditions for the formation of the Frankel defect. As in the Schottky defect, we already learned the conditions and consequences of the Schottky defect. Similarly, here are also the condition and consequences of the Schottky defect. But these are totally different or opposite that of the Schottky defect. Now, the first condition from the Frankel defect is that Frankel defect occurs in the ionic compounds with large difference between the sizes of cations and anions. Now, we learn about the Schottky defect. The first condition is that defect, Schottky defect is also for the ionic compounds. There are also cations and anions, but they are of the similar size because their radius ratio is not more than unity. We learn about that. But here, the Frankel defect occurs in the ionic compound with large difference between the sizes of cations and anions. Generally, cations are smaller than the anions. Because of that, cations occupy the interstitial site, so it can be accommodated into that due to its site. So, there is the first condition for the Frankel defect is that the Frankel defect generally occurs in the ionic compounds when there is the large difference in between the sizes of cations and anions. The second condition is that the ions of ionic compound must be having low coordination number. Now, this is totally opposite that of the Schottky defect. In Schottky defect, we learn the second condition is that in Schottky defect, the coordination number of the ion, that is the anion, is it is always that is the more into that. But here, in this Frankel defect, the ions of ionic compound must be having the low coordination number or small coordination number. Now, this is the another condition. Now, see the consequence, that means effects of the Frankel defect. What are the effects or consequence due to the Frankel defect? The first is consequence or effect is that as no any other ion or no any ion are missing from the crystal lattice. The ions missing from its original position, but they do not miss the total crystal lattice. That means the ion, though it lose its position or original position, but it shift to the interstitial space. That means no any ion is missing from the crystal lattice. Due to that, what happened? As no ions are missing from the crystal lattice as a whole, the density of the solid and its chemical property remains unchanged. That means the cation generally lose its original sign, but it always occupy the interstitial space in the same crystal lattice. So as a whole, there is no missing of any ion, and therefore the density of that solid remains unchanged. That means same or constant. And again, as there is no missing of the ion from the whole crystal lattice, its chemical property also remains unchanged or constant or same. Now this is the first effect or consequence. The second, the crystal as a whole remains electrically neutral, because though the cation miss its original position, but it remains in the same crystal lattice into the interstitial side. So there is no question of any change in the electrical properties. Both the numbers of cations and anions remain same in the crystal lattice. So the electrical property also remains unchanged. So the second consequence is that the crystal as a whole remains electrically neutral, because the equal numbers of cations and anions are present in that lattice. Now the third here, that is this effect is found in ionic crystals like zinc sulfide ZNS, silver bromide AgBr, silver chloride AgCl, silver iodide AgI, and calcium fluoride, etc. In which generally all these cations, zinc, silver cation and calcium cations, having the smaller size than that of the anion, that is such as sulfide ion, bromide ion, chloride ion or iodide ion. So generally this Frankel defect is found into this ionic compound, zinc sulfide, silver bromide, silver chloride, silver iodide and calcium fluoride. Now student, this is about that is the Frankel defect, which is the fourth point defect. Now if you understand very well this defect and its effects also, that is the consequence of this Frankel defect, conditions of this Frankel defect, and about that is the figure which we draw here, and how it is the combination of both defect, that is the vacancy defect and interstitial defect. Then student, you can share, like and subscribe this video, and also you can tell to the another students of the 12th science to like and subscribe and share this video and watch this video, as they also got benefit and they can be easily solve the entrance examination questions such as JEE, NEET and that is the Maharashtra CET. Thank you for watching this video.